session by delivering by Pooja Sharma ma'am on pathway towards deep learning. Before we start this session, I would like to introduce the session expert of the day two, second day one, session two. We are delighted to introduce Ms. Pooja Sharma, an accomplished professional with extensive expertise in training, development, and technology enablement. With a strong passion for empowering learners, she has made a significant impact in delivering corporate training, boot camp, and skill development program tailored for working professionals. Currently serving as a lead technical trainer at Simply Learn, Ms. Sharma excels in designing and conducting high-quality training sessions in cutting-edge domains. Her area of specialization include artificial intelligence, machine learning, generative AI, and open AI technology. Her core strengths lie in crafting and delivering impactful, result-oriented training programs, expertise in emerging technologies with a focus on practical hands-on application, creative interactive learning experience through innovative project methodology. We are honored to have Ms. Pooja Sharma with us to share renewable insight and expertise in this session. I request ourselves to please turn off his camera. Yes.
Yes, ma'am. Yes, ma'am. Ma'am has now been a host.
Okay. So, ma'am, over to you.
Welcome, Pooja, ma'am.
Thank you, everyone, for inviting me. Let me just start the session.
Yes, sure, ma'am.
Participants are requested to mute their mic so that we can hear the experts. Ashish sir, please mute the.
Yes. Yes, ma'am. Done.
Yes. So, very good evening. Present here, myself, Pooja Sharma. I will be the trainer for this particular session, and I pay my gratitude to all the organizing committee for inviting me for this session. Thanks, the organizing committee. Now, I hope everyone is able to see my screen.
Yes, ma'am.
Yes, ma'am.
So, this is AICTE training program in the preserving local dialects using multi-layer perceptron for sustainable development of communities. And here we are talking about the session here in the pathway towards the deep learning. And I welcome you all for this session. And I'm working as a technical trainer with the data and AI track with the Simply Learn. And let's get started. So every session has the learning objective. So what are we going to learn in this session? So as this session is going to talk about the deep learning, so we must know about, first of all, the achievements of the deep learning in the past decades. We want to understand the applications, challenges of deep learning. Also, what are the different framework we are having? Those facilitate the development of deep learning models, including their features, uses. And if I want to create a project using deep learning, so what will be the end-to-end process? How I need to start? What is the planning phase, data collection to training, evaluation, deployment, and the monitoring? Also, along with, we are going to talk about the various types of deep learning models. So let's get started without wasting time. I hope every one of you have seen this wheel where the outer one, we are talking about the AI. Artificial intelligence, where we want to mimic the human intelligence, as human is able to take the decisions in the real time. We want to train our machine in such a way so that it can also take the decisions like the human beings can take. So AI is the whole word we have. Inside that, when we talk about the machine learning is all about when we are training our models with the help of some data set, right? And here, what is our basic objective? Our basic objective is to do the predictive modeling. When we say about predictive modeling, it means we want to predict, we want to forecast what will be the temperature tomorrow, what will be the weather, what will be the stock price. So that will be covered under machine learning. Now, when we talk about deep learning, which is also a subset of machine learning, we want to focus on the complex problems. We want to solve the complex problem through the help of deep learning. Complex problem, where like I want to learn from images, from videos, from large text data. So there we need the deep learning. So we want to have a discussion about in the evolution of AI in artificial intelligence. We started from the year of 1942, 50, and there are a lot much evolution happens in the past year. Now this is the golden period of the AI, machine learning, deep learning techniques, because in this arena we are going to work with the computer vision, the natural language processing techniques the most. We have a huge computation power nowadays in terms of GPU, CPUs. So it is possible to work with the large data sets, to work with the large computation power. And that is the evolution of AI we can see all around us. Now, first of all, the question comes, what motivates us for deep learning? So the deep learning motivated by with the key developments in the field of deep learning. And what are the key development we have? The development in terms of different neural networks in the field of deep learning. So to solve variety of complex problem, we have various types of neural network family. Like we start with simple perceptron model, normally used for binary classifications. We have multi-layer perceptron where we use multiple layers for the processing our inputs to output. Here we can use the feed-forward neural networks. We use backpropagation techniques to improve the learnings of our neural networks. Other than that, we also have other family of neural network. One is convolutional neural network, which is especially we use for the dimensionality reduction. We use it for the image classification applications and all. I'm going to discuss into the deep. And we also have recurrent neural network. Recurrent neural networks are used to work with your sequence data. So what type of data we call as a sequence data? That follows some sequence. Like some task happened at task time t1 and some task happened as time t2. So there is a relation that whatever the task happened at task t2 is related with the task t3, right? For example, your stock market data, your weather data, your forecasting data can be solved with your recurrent neural network. Also, when we work with the word sequences, when we work with the text data, I want to predict the next word which will come. For example, when you use Gmail, you just type please find. So attachment is suggested to you. How it is happening? Such kind of applications we can develop through the recurrent neural network. Now, so in the case of deep learning, we have variety of neural networks, and that is because we have several types of neural network, which is one of the motivation to work with the deep learning. Now, I want to develop several applications using deep learning. So first of all, I need to know that what type of real world problems can be solved with the help of deep learning. So as I told you, the deep learning is being used to solve complex problems. Like the complex problems I can solve, one of the problem is like image recognition, right? Now, what type of application comes under image recognition? I want to train machines in such a way so that it can identify, classify objects within images. So what type of applications come under image recognition? I'm going to give you example. Let's talk it about image recognition like this. Like one of the domain of the deep learning is to recognize the images, right? For example, I have one picture where is one person is carrying his dog, right? So I want to identify what are the objects present in the images, and this comes under the area of the computer vision where we recognize the images. So such type of applications we can develop using the deep learning. Now to do this, what neural networks we use, what models we use, we are going to discuss. The another exciting area which we can use for the deep learning is natural language understanding. So what projects we are doing using language data? So language processing, it means I want to make certain projects regarding, for example, language translation, text summarization, text generation, text classification, where I have a huge amount of input text data. You have a Twitter data, you have your LinkedIn data, you have your company documents, you have email data. So you want to teach the computers in such a way those can teaches computer to comprehend and process the human language. Nowadays, everyone can see the examples of large language models in front of us, like ChatGPTs, Google, Bert, Llama. All these large language models are able to learn from the text data and able to generate your text, comprehend your text. So understanding the human language can be done through the variety of neural network, like we start with RNN, LSTM, long short-term memory. We also use transformer-based models. So using these, such area is covered, which is natural language understanding. Also NLG, also natural language generation. Then we also have a speech recognition. Like we want to enable computers to transcribe and understand the spoken words. Nowadays, you can see that we can talk to the machines. Like I wanted to ask to the Alexa that play these songs, or I want to ask to the machine where I purchase any product from Amazon and I'm giving the review by recording my voice. So here the computer is going to transcribe, it will understand your spoken words. So one of the important area here in the deep learning is again speech recognition, right? So deep learning is going to solve the real world problem in the field of image recognition, natural language understanding, speech recognition, right? Now, how we start working with these projects, what are the frameworks do we use, that I'm going to discuss. Now, when we talk about deep learning, guys, we need to know about what things motivated to work with the deep learning. For example, there is a requirement for deep learning or machine learning. How much the large amount of data you have, better the accuracy of model we have. So this graph something look like this. How much, the amount of data you have, you will have a more accurate models, right? It means the question comes that I want to make some image recognition softwares. I want to make some image classification softwares, right? So how can we work? So in that case, the evolution started. There is a paper came in the year of 2012. And here the proposed neural network was ALEXNet. ALEXNet what? The one of the first deep learning paper which achieved the state-of-art performance in the ImageNet challenges. Like guys, I want to make an image recognition software. So I need millions of images. So there is a images we have there is a publicly available data set we have that we call ImageNet dataset. In this ImageNet dataset, we have total right now 1.2 million images for the training data and 1.5 million images for the test data. And the images are classified into the 1,000 categories, right? So this ImageNet challenge happens every year, 2012, 2013, 14, and various neural networks participate into this ImageNet challenge to solve the classification task. So the various neural networks like ALEXNet, VGGNet, InceptionNet, MobileNet, or these Google Net, these model came, they worked on these millions of images, exhibited their best accuracy. So these models are available for you that you can use in your own programs also as a pre-trained neural networks. And then you can also achieve the state-of-art performance. So if you do not have a massive data set, you can use these pre-trained models. They also shown their good accuracy on these public data sets. So all these you can find with the deep learning libraries like Keras and TensorFlow. So this is first thing we have in the case of deep learning progress. But the problem comes in the deep learning, the challenges we come is the lack of funding we have, inadequate hardware, and the expensive data storage, right? For example, if you do not have the sufficient computation power, if you do not have sufficient GPUs, you cannot train the large models on the massive data set. Also, the data storage is also expensive, right? So just after, I'm talking about the progress of the deep learning. So now let's come to the proper definition of the deep learning. What deep learning is going to, how the deep learning is going to help you out. So deep learning is which is going to focus on to learn the complex pattern from your data, right? Like it is a subset of machine learning. What is machine learning? Where we use some statistical methods to predict the outcome, like whether it will rain or not, the transaction is fraud or not, right? The mail is spam or not. Where deep learning is focusing on the complex pattern of your data, right? And they want to make some intelligent decisions from the large data set, correct? So if I enhance the definition part, the deep learning can help you out to understand the image data, text data, audio data, video data, right? And here we can discover the patterns, make accurate predictions and the classifications. So what deep learning can do? Deep learning can work with your unstructured data, like large set of images, text, audio, and video. Now, so deep learning is going to surpass the traditional machine learning processes where it is giving you the superior performance in the world of computer vision, natural language processing, and the speech recognition. How? Because it is able to extract complex features. And here we are able to achieve the high accurate predictions on the classifications, right? So I would like to make you this definition easy to understand. What is deep learning? Deep learning, where we want to extract useful patterns from our data. Now, what we understand with the patterns, I have some image data. I want to do a face recognition software. So I can create such neural network that will learn layer by layer the features from the images. Like the lower layers will learn the initial features, then we will learn the middle level features, and then we will learn the high level features like the facial features, the the shapes present in your data that we can learn. Question comes how it is happening? Because we use the efficient neural networks, right? And we use the optimization technique to get the result uh, of the particular program. So how it happens? We use the neural network. We use a proper optimization strategy. And why now? Because why we are able to fulfill these things in today's world? Because we have ImageNet data set. We have certain public data sets available. Those are large in size, will help you out to train your models. We have nowadays the efficient, proficient hardware in terms of the NVIDIA GPUs that you can use to train your models. We also have the frameworks like Keras, TensorFlow, PyTorch. Those are efficient libraries are going to help you out to train your deep learning models, right? So I hope you are able to understand what is the definition part of the deep learning. Now, how this revolution is going to happening, why we are able to see a lot many products around us using the deep learning. So there are three key reasons we have. the availability of large data sets, right? Like we have ImageNet data. Similarly, we have COCO data sets for object detection part, ImageNet data set for the purpose of the image recognition. We have efficient learning algorithms also, like ANN, RNN, CNN, LSTM, transformer models, diffusion models, right? So these algorithms helps to understand your data well. And nowadays we have huge computation power in terms of the high core processor CPUs and the GPUs. Those help you to work with the deep learning, right? So if I talk about the deep learning success in the last decade, so deep learning has experienced exponential growth in the many of the area, like computer vision. Like what is computer vision? I just wanted to discuss many of the applications. So first image, if you are able to see on my screen, the first application is related with image classification, where I want to create a project where I want to identify what object is present in the image. So this is image classification, whether it's a taxi or whether it's a car or whether it's a bus or whether it's a truck. So I'm going to classify the input image into some of the classes. And that application is called image classification. This you can make using deep learning. The next exciting application that I have is called object detection. Now guys, what is object detection? In case of object detection, here you can see in this image, several objects are present, like bus is there, like car is there, like there is a cyclist, there is a pedestrian. So what the object detection model does, they create a boundary box around every object present in the image. So object detection perform two tasks together. What two tasks it does? The first task is detecting the object, or that we call as a localization, right? It localizes where the object is present. Also, it also gives the label to the object, like where the object is present and what object is present, right? So object detection perform two tasks, localization as well as classification. Now the another application that we have is called semantic segmentation. Guys, image segmentation is of two types. One is called your semantic segmentation. In the case of semantic segmentation, we want to classify each pixel position, like we want to identify what particular pixel position represents. Like I want to identify how much the ROI, how much the area covered by this bus in this image, right? Or for example, let me take another example. I want to check the person is wearing a mask or not, right? Or I want to check how much there is a total spread of a particular disease in the image data set. So here we can use the segmentation techniques, image segmentation technique. There are two types of semantic segmentation we have. Instant segmentation we also have. So we want to focus on the every pixel value, what they are contributing in the case of segmentation projects. And here we have so many models to work with the semantic segmentation. Like in object detection, we can work with several models, like you can use CNN, faster RCNN, RCNN, YOLO, and there is a family of YOLO models nowadays we have. Those are helping you out for the object detection task. Similarly, for the semantic segmentation, also we work with the various segmentation processes where we can focus on the specific, like we have models like UNet. There is a variety of UNet models we have. Those help you out for the segmentation process. Now, the next application which you have ever seen in your smartphones also, whenever you click on picture, there is a caption comes that what is happening in this picture. So the caption is that there is a person with a dog on a street, right? So this image captioning is also one of the application which we can develop through the help of the recurrent neural networks. Also here we can use convolutional neural network to extract the pattern of the data, and then the caption can be generated, right? Some advanced applications, if you want to make, then you can target each and every individual in the image. You can recognize the face. You can count the number of persons visiting this area. You can see any violence happening in the area. You can do the real-time video analysis also using face detection and recognition, right? This is also possible with the help of the deep learning. Also, one of the interesting domain of deep learning, which is we called OCR. What is called optical character recognition? Optical character recognition, guys, as for example, you taken a food from a restaurant, you took dinner from a restaurant, and there's a bill generated through the restaurant. Now, you wanted to read all the text written on that bill. So you can generate a product, you can generate a project, OCR, optical character recognition, which will read the data present on this image and will give you the output. So there are several libraries we have in Python to do the OCR task, right? We have like Keras OCR is a library, and also interesting other libraries we also have in Python, very, the proficient libraries. Those will help you out to make your OCR projects. All these applications you can do in the deep learning using the Python libraries available. Also, you can use the pre-trained models to make all these object detection, semantic segmentation, all these tasks, right? So the very first area, the exciting area of the deep learning is computer vision, when people want to work with the images, right? Or the video files. And now also we can do the projects using the audio processing. You can easily process your audio data. You can easily process your the audio files. You can see where actually the speech is present. You can analyze that speech using deep learning technique, and here you can understand the words, and then also can predict the behavior. So many interesting projects we can do with the audio processing. And similarly, in the reinforcement learning, where there is an agent, there is an environment, the agent want to maximize the rewards, right? So such environment also we can do with the help of deep learning, right? Just to confirm, am I audible with everyone? Am I connected?
Yes, ma'am.
Right, thank you. So now, after talking about these applications of computer vision and everything, so we have several pre-trained neural network models available. Those are going to help you out in any of the field. For example, we have an ImageNet dataset. This ImageNet dataset is publicly available, where we have millions of images. This dataset has thousands of classes. So there are the first neural network which came, AlexNet, and this is the architecture of this AlexNet neural network, where we use some convolutional layer, then max pooling layer, then convolutional, and the pool of all these layers, and then we come to the final classification. So this ImageNet helped researchers to understand that how we can do the image classification. This model exhibited the good performance in the year of 2012. Then after several other model came. If you want to see all these models, you can go for the Keras applications. In the Keras applications, you will find all these pre-trained available models. And these models we can use directly in our programs for the image classification purpose. Now, after talking about the world of computer vision, nowadays everyone, when I say everyone, it means yes, everyone using ChatGPT, everyone using Google Gemini, Llama models for variety of tasks. And these all are the product of generative AI, where we are generating some novel content, we are generating some images, videos, and so many things. So suppose you are typing a prompt, you are typing a query, you are typing a prompt, input prompt, that I want to understand how to create a web application in Python, for example. So I'm writing a prompt in ChatGPT. Now you are writing your human language, correct? Which is you are writing the prompt in the English language, human language. Have you ever thought how ChatGPT understand your query? How every model understand your query? So this is my human language. It means the human language. And what are models? Models are nothing. They are mathematics. They are applying some mathematics. So they want the data to be converted into vectors or in the numbers. So here your data, when your input query, how all these chat GPT understand, they convert your input query into word embeddings. What are called embeddings? The vector representation of your input data is called your embeddings, right? So now there are various techniques we have to create these embeddings. If we start with the from basics, we create bag of words model. We have several NLP technique to create these embeddings. One of the embedding technique is word to vec. Here we use a Python library Gensim, which is used for the word embedding purpose. And nowadays we also have various word to vec embedding technique where every word will be converted into corresponding vectors. Vector is what? A mathematical vector we want to generate. For this purpose, we also use several embedding techniques with the available with the transformers, with the models like TensorFlow. Word embedding, it means the dense representation of your text data. And this is a input pre-processing step that we use whenever a prompt is given to all these tools. So word embeddings, we used to use the word to vec model. Nowadays we use transformer models. Those use the like my next discussion is just that also. So in the year of after 2000 the 12, in the year of 2013, the word embeddings we started working, where we wanted to convert the word into the corresponding vectors. Then in the year of 2014, we are talking about sequence to sequence models. First of all, we need to understand what is sequence to sequence. Like, let me take one example of an application like language translation. Right? I hope everyone used Google Translate to translate one language into the another language. Like when I want to translate from English to French, for example, I want to translate from Hindi to French or German to Spanish. So guys, please, here we can see that input is also a sequence. Like you are giving some English sentence, right? Which is sequence. Why I'm calling a sequence? Because, for example, there is a sentence. Today we are going for a picnic, right? This is English sequence. Now I want to convert into a new sequence. Suppose I want to convert it into another language, which is suppose the French language, right? I want to convert into the French. So French will also be a sequence. So such model, those can convert your sequence to sequence. In this case, we use several neural network, right? For example, just a second. So we use various sequence to sequence model. Now in this sequence to sequence model, one of the very popular model which came in the year of 2014 is RNN, recurrent neural network. What is a recurrent neural network? Recurrent neural network remembers the latest sequence. For example, it can remember you are training your RNN. For example, the sentence is the clouds are in the sky. My sentence is the clouds are in the sky. So with this sentence, you trained your model. The clouds are in the sky. So it can predict, if you're writing the clouds are in the sky, it can predict that the next word will be coming as a sky. So it can predict the next word in the sequence. So recurrent neural network type of neural networks, right? Where we encode input sequence into a vector, and then decode the vector into the different sequences. So here what we are using, for example, there is a sentence we are using in one language. The one language, first of all, will be encoded through the RNN, and then it will be decoded into another language like this, right? So here we use the RNN. Similarly, the other model also came, LSTM. The full form of LSTM is long short-term memory. So both RNN and LSTM were able to work with your sequence data, right? But they were facing some issues. Like RNN and LSTM are very good when you want to work with your short-term sequences. Like if you are asking RNN and LSTM to remember small sentences, it can learn. But suppose if if I'm giving a large sequence and if I'm asking it to give the answer for the large sequence, then these RNN and LSTM cannot remember your large sequences, right? For example, I'm writing about John. John lives in France, right? He speaks the language French fluently, right? He is an artist, right? Now I was talking about John. Now after 2-3 sentence, again I'm talking about John. So these RN and LSTM cannot remember about that user context because that you talked before so long. So what is the solution for this? Which model came to overcome this? I'm going to discuss. Now which model came? I would like to talk about the transformers, right? So before talking about the transformers, now we also have one model came in the year of 2014, and this is also one of the prominent deep learning neural network. And the name of the neural network is called GAN, right? So the GAN is actually used in the world of generative AI. And what the GAN can do? Guys, nowadays, I hope everyone have seen this deep fake technology where we can generate some deep fake images. So how this is being generated? So in the GAN architecture, we have two neural networks. One is called generator, other is called discriminator. Like generator generates some samples. So generator never seen the original images. It randomly generates some image and gives to discriminator. Who is discriminator? Who's seen the original data? Who knows how actual images looks? So it compare your generated images with the actual images and declare you are fake, right? No, your generated image is not correct. When it declare you are fake, this feedback taken by generator and it improves its generating quality. Then it will also again generate the images and give to the discriminator. So here we do the adversarial training. Both are opponent to each other. Both are trying to train each other. The generator would like to generate images in such a way so that the discriminator cannot discriminate that which is a true or which is fake. Whereas the role of the discriminator to discriminate the generated images and the fake images. And its aim is to label you that you are fake. In this way, both learn, right? So GAN is a type of neural networks in the deep learning. Those can generate synthetic images, new images for your data. And nowadays we have a variety of GAN applications like cyclic GAN, style GAN, pix-to-pix GAN, right? And they can be used in many variety of applications like in the fashion application, art application, or also in the science applications, right? So the GAN is used to generate your image synthesis applications and your the applications which you can use to generate new data. Now, we also have various advancement after the simple GAN models also. You can work with variety of GAN as per your requirement. Now, in the 2016, there is a game came, AlphaGo, which beats human. And Go is a more complex board game than chess. It's a reinforcement learning model, has achieved mastery in the game of Go. And now, guys, this discussion I wanted to keep when we are talking about deep learning and when we don't talk about in this world of transformers. So transformers are what? In the year of 2017, there is a paper came. The paper name was "Attention is All You Need," right? The paper is, we must pay the gratitude to the author Vaswani, and sorry if I'm forgetting the name. The paper is the base paper, which is a revolutionary paper in the field of the natural language processing. So what was the shortcoming of these RNN and LSTM models? The shortcoming of these RNN and LSTM model that they were not able to learn longer sequences. They can forget, right? Also, their training was sequential. Whereas when we talk about transformer models, their training was parallel. And the key idea behind transformer was self-attention. That what is the meaning of self-attention? That it want to give the importance to the word which has a higher importance in a particular sentence. For example, I have a sentence, switch on the lights. So light is the most important word here, which to be given more attention, more importance. So transformer model use the concept of self-attention. They calculate the self-attention for an individual word, and accordingly they do the encoder-decoder architecture. So transformers are the base models nowadays, which you can see the products of generative AI, deep learning nowadays, which are your GPT models like ChatGPT models. You have BERT models, you have LLaMA models, large language models. All are based on the concept of transformer encoder-decoder architecture, right? Now, what is the success of deep learning in the last decade? Who is going to help the research community to explore the deep learning a lot? So if you ever heard, there are some Python libraries we have to work with the deep learning. Like one of the prominent library of the deep learning is a Keras, TensorFlow, and the PyTorch. Keras is actually your front-end API that works along with the TensorFlow. TensorFlow, here we can work as a backend with the Keras TensorFlow integration. So those who are beginner, those who are working with the deep learning very first time, they can work with the Keras TensorFlow applications. These are very powerful libraries. They are developer friendly, and they allow you to generate the product faster, right? But here you will find more abstract code rather than more opportunity for the debugging and the coding. And for that purpose, we have the other library, like we call as a PyTorch, right? PyTorch is more about if you are good in object-oriented programming, here you will be creating the classes for your neural network. So guys, concept of neural networks are same, but PyTorch is basically you can use when you are working with the large data sets. You can see the training time is reduced when we are using PyTorch, more debugging possibilities, more support to the GPU's functions, right? So if you want to learn all these frameworks, their corresponding official websites are available. You can go through. There you will find so many examples to learn all these frameworks to work with the deep learning, right? But I suggest if you are beginner, you must start with to work with Keras, TensorFlow, and then you can work with the PyTorch also. So why we are learning deep learning? Because deep learning solving a lot much industry problems, right? Uh, like you can see that nowadays, guys, whichever the thing we are talking about, image classification, object detection, all these things happening in a real time. Yeah, right. If you want to see that, like let me show you. There is a procedure that we have which we call how the China tracks everyone. If you want to see that are these applications really used in real time? Yes, guys, all these applications are deployed nowadays everywhere. Let's just skip this advertisement. So yes, I would just would like to show you one interesting video that we have, how China tracks everyone. So whenever you get time, guys, please see this video completely. What I'm trying to say, they have installed cameras, surveillance cameras, everywhere. They are clicking the images. They are recognizing who is present on this on the road. They are, the continuously doing the video surveillances. Whenever you go to the restaurant, everything is totally automated through the AI tools. They are doing the face recognition systems. They are doing emotion recognitions. They are doing your age calculations. They are doing how many vehicles are going on the road. They are also checking about is any violence happening on the road. So totally possible all these with the help of all these computer vision applications, right? So they are tracking everyone through these object detection, through these all applications that we have. So whichever I talked with you, the applications related with the language models, related with the computer vision models, all these happening in a real time. And we are detecting the objects present in the image. We are doing image classifications. We are doing segmentations. We are doing face detections, recognitions. All these applications installed and working in a real time, right? And who is the behind of all these things, these interesting models used for the variety of tasks to generate images, to convert the text data into the proper embeddings, right? And these deep learning libraries. So why we are learning the deep learning? Because deep learning is solving the variety of industry problems, right? Autonomous vehicles, robotics, and the one of the key reason to go for the deep learning is the powerful the GPUs are available, right? You can the NVIDIA launch the CUDA framework, which provide the API for the GPU computing. So why we need GPU? Because to work with a large data set, to render the patterns of the large data set, we want to large training time, which is not which cannot be done through the CPUs. So here we need the GPUs. You can also rent it from the cloud providers like AWS, Azure, which we can also use, right? Those who are beginner, we can work with the Google Colab. Google Colab also offers you the free GPU support that you can use uh, for the purpose of deep learning, right? Now, but when you start deep learning, what you must know, you must have a knowledge of Python programming, because all these deep learning applications which we are developing being done through the help of the Python libraries like Keras, TensorFlow, PyTorch. There you need to write the program, so you need to know the Python. And somehow you must be aware with some terminologies like supervised learning, unsupervised learning, classification, regression, statistical models, some distributions, some basic linear algebra. Because when we work with the data set, you need to know about how we do the basic linear algebra, some distributions. So all these things are somehow we can call as a prerequisite when we start working with the deep learning models, right? Uh, Now also why everyone is going to learn the deep learning, the reason is that the application areas, right? The industries are nowadays, you can see the jobs created in this market of AI, generative AI, and all this deep learning. People are companies are looking across the trained professionals in the field of deep learning, because deep learning is going to help you out in many of the areas, in healthcare, for drug discoveries, for disease predictions, for a variety of tasks, for assisting the in the case of doctors regarding the cure of the particular disease, finance, retail, manufacturing, transportation. everywhere. These nowadays surveillance cameras being installed where automation is there. So there's a shortage of trained professionals in the industry. So there's a, the key reason is to get into this field. So we discussed there are the variety of applications of deep learning we have. The deep learning is there in the field of computer vision, where we work with the images. Like if you have ever seen that how self-driving car works, like how we look at and the road and we identify that this is a car, this is a truck, this is a pedestrian. The same way the self-driving car looks on the road by using the object detection techniques, and it classify the object present on the data. Self-driving car is not a product only for the deep learning, but it is here we use the interdisciplinary, like we use cloud, embedded systems, sensors, many other things also work. But the computer vision techniques helps it to identify the object present on the road. Here we use deep learning for the purpose of the audio processing. We can do the colorization of black and white images using deep learning, right? NLP, as I already discussed, nowadays, whichever the LLM models you are able to see, where we are giving the input as a human language, and we are generating the text, we are summarizing the text. It is all happening with the applications of deep learning, right? But wherever we have a lot many applications of the deep learning, we also have some limitations. And the limitation is that I want to start with my own project, right? I want to work with on my custom application. So in that case, first of all, the requirement is a huge data set, right? Because if you have a large data set, you will get a good accuracy about your model. So the challenge, the very first challenge that we have, how the huge data set to be collected, prepared, and the labeled, right? So here also you need to have a help of a domain expert, those who are going to help you out for the data collection. But that to be for data collections, nowadays people use the third party tools also, some annotations tools you can use to annotate your data. So one of the limitation of the deep learning is collection of data, collection of massive data set, large data set, right? So suppose you collected your data. Now the other challenge is that once, for example, you are going to make a project, cat dog image classification. So I need to collect so many images of the cat and dog. Now, if I'm using a supervised learning, the data set to be labeled properly, right? That I need to know that this is a cat, this is a dog. So here, if they are not labeled properly, you need to use some data annotation tool to label them. For segmentation projects, you need to create segmentation part also. So again, when you collected raw images, again, a data pre-processing is also required to label them properly, to pre-process them properly, because the quality of the deep learning project is totally dependent upon your quality of input data, right? Again, you must have high-speed RAM and GPU. If you do not have, you need to rent to the cloud softwares, or you need to purchase the hardware, right? Also, if you give there is a sufficient training. If you do not have, the model will be overfitted. Overfitted, it means your training accuracy will be good, but when you will deploy your deep learning models to the client side location, the model will be overfitted. The model will not exhibit the same performance at the time of training it is showing. So here you need to give the sufficient training to the model also, so that the model outperforms not only on the training data but also on the test data also, right? Okay, if the model is overfitting, then you need to find the solution to overcome it. And this is a common phenomena. Our ML models and deep learning models faces the overfitting, right? Also, one of the limitation of the deep learning is also, deep learning is, guys, something like a black box. Because somehow in the machine learning, we can interpret how the predictions are happening. We can interpret that, suppose if the temperature is high, the humidity is down, we can interpret how any machine learning algorithm like KNN, naive-bayes classifier, decision tree is predicting the outcome that yes, it will rain. So we can understand the mathematical relationship that because the temperature is high, humidity is low, calculation happening through some classifier, and the rain is happening. Somehow ML models, we can understand because we can do the calculations. But if we talk about deep learning models, in the case of deep learning models, because we have so many deeper layer, the layers in the deep learning models, and due to that, we cannot understand, how the predictions are happening. So nowadays, we have a solution for that also. Nowadays, we are coming with a solution that those help you out to understand the internal working. And there we want to use in, the AI techniques. Through some library, we want to interpret the deep learning models also. Right. Now, after talking about the application part, the frameworks part, now, uh, what is the life cycle of the deep learning project? So, when you want to work with the deep learning project, you want to use certain frameworks, which I discussed, like Keras, TensorFlow, PyTorch. TensorFlow was developed by using Google, and you can do coding with the Python. And TensorFlow use a computation graph. It uses a computation graph to optimize your problem. Keras is a Python library used to create your neural network. And similarly, the PyTorch, which I already discussed, which is a capable to work with a large data set. Right. Now, this is the diagram which we are using to understand the deep learning life cycle. So for every AI project, if I have, it's a machine learning project or it's a deep learning project, we start first of all the planning phase. What project are we going to make? So suppose if the project is simple image classification, I want to classify the image belongs to the category X or category Y. So I need to do the planning. Now, according to that, I need to collect the data. Now, for the data collection also, you can use some statistical techniques. You can collect the data from the real-time sources. You can collect the data from the sensors, or you can take some data, publicly available data set also you can use. But if it is your completely custom data, then labeling to be done at your side. If it is a supervised learning data, you need to label it properly. You need to create proper folders, hierarchies, and everything. Then after choosing the proper framework, uh, right, we need to start the training phase. In the training phase, guys, what happens? For example, I'm going to create a simple neural network for the purpose of image classification. So we train our model with the help of all the data set available, right? Then we test the model, that is it exhibiting the required accuracy or not. So suppose if you are not getting the proper, the accuracies, we need to reduce the errors. We need to optimize the errors in such a way so that it get the proper result. And then finally, we can deploy it on a particular platform, like whether it's a cloud platform or a edge devices or a mobile devices, or I want to create a proper web application for the same, for the deployment part. So this is the life cycle for the deep learning projects we have, right? First is the planning, then data collection, then the training. Yeah. So in the training, we train our neural network with the training data. Then we use some technique like backpropagation. And there we do the iterative updates to get the proper output. And then after we evaluate our model. So now, so these are the techniques that we used for the purpose of the end-to-end life cycle of the deep learning project, right? So before proceeding ahead, just I would like to have a small question. Okay, I think ANN I have not covered. Okay, no problem. Yeah. So what kind of hardware is required to train deep learning models? It's a low-end CPU with minimal RAM, high-end CPU with sufficient RAM, good quality GPU with sufficient RAM, or specialized hardware like ASIC and or TPU. You can give the answer in the chat box also. To train our deep learning projects, what we require. Is the answer? Yes, you can use chat box for your answer also. Yeah, it's the answer 3, correct. We require the high-end GPU, right? So now the next question I want to ask, what are the some popular deep learning frameworks we have that you can use to develop the deep learning projects? TensorFlow, Keras, PyTorch, MATLAB, R, Octave, Spark, Hive, Hadoop, or none of the above? Let me check. All of you are agree on which particular answer. I hope everyone is looking on the response options. Yeah, right answer is correct, A. Yeah, thank you. Now, guys, till now, we learned about the basics. That what is deep learning? Deep learning is a subset of machine learning where you want to target the complex patterns, right? And we have certain types of neural networks to fulfill all these requirements, the framework and the life cycle. Now, in the whole discussion, I'm using several times a term which we call neural network, right? The deep learning, all the algorithms, models using neural network architecture. And we have variety of neural network families, right? So first of all, we need to understand what we call as a neural network. So guys, this word neural network is being inspired from the human brain, right? It is inspired from your human brain, right? Why I'm saying that it is inspired with the human brain? The word which you are listening, neurons. So as we have the arrangements of neuron in our brain, they are interconnected together, right? They receive the input, they do the processing, and then they generate the actions. The same way we have the neural networks, where we have the input layer, we have the hidden layer and the output layer, right? So for example, I want to make a simple application that whether I need to the go to watch the movie or not. So the input layer will have some features like who is the director of the movie, right? Who is the actor of the movie, right? What is the storyline of the movie, right? Now with these input, for example, uh, by passing these inputs to the neural network, the hidden layer will do some processing, and at the output you will be getting an output. The output may be either yes or no, that whether you will want to watch the movie or not. So in this way, neural network will receive the input and will generate the output. So each neural network consists multiple nodes such as input layer, hidden layer, and output layer. Now the question comes, the difference actually I would like to show you, the difference between simple neural network versus deep neural network. Guys, simple neural network where number of hidden layers are very less, right? When the number of hidden layers, the processing layers are very less, it is your simple neural network, right? But when we say it's a deep learning neural network, where you have so many layers for the processing your input data, right? Do you know the models which I'm talking about, VGG 16, 19, Inception Net, Transformer models, they use 16, 19, 22, so many layers for the processing the large amount of data. So deep learning, where the number of layers, the hidden layers are more, and they are going to process the complex data, right? So where we use the deep learning. Now, as I was telling you, first of all, what is called the neural network? Neural network where we have input layer, number of hidden layers, and the output layer. So what each neural network does? Each neural network takes the input, pass through the hidden first layer, then each individual neuron receive as an input and assign weight to them. Now I'm using a new term here, weights. Guys, here we assign. Weights are what? We assign input is to be multiplied with the corresponding weight. right? And we add some bias term also. So each input will be multiplied with the corresponding weight. Now the question comes from where these weights will come. These weights are initially randomly taken, right? These weights are initially randomly taken. Now suppose I have taken the random weights, then I will generate the output based on the assigned weights, right? Now the output from the first layer are subsequently forwarded to the second layer for the further processing. So what happens? I assigned the random weights and then I got the output. If I'm working with the supervised learning data, I already know the actual outcome, right? So in the neural network, actually the training happens to identify the correct value of these weights, right? How neural network learns? You cannot change the input because you are learning with the data set. Data set is fixed. You cannot change the input. You cannot change the output because you are working with the supervised learning data. What actually the model will learn, what actually the neural network will learn, the correct values of these weights. For example, I taken this data from a university. I collected some data from a university that are you going to watch the movie or not? So I'm putting several director name, several actor name and storyline and other features. Now I'm able to see whenever the actor is X actor. For example, whenever this actor is there in the movie, everyone is going to watch the movie, no matter what is the storyline, who is the director of the movie, right? So the outcome is actually dependent upon who is the actor in the movie, right? It means who is the most important feature here? What is the most important feature here? Actor. So what the neural network will try to learn? The neural network will try to learn that while calculating the answer, it must give the higher weight to which particular input? Actor. Why? Because it is able to see in your data set, whenever in the column actor, this X actor is there, answer is yes, right? Whenever this actor is there, answer is yes. Everyone is going to watch the movie. So actor is the most important feature. So its weights to be more than the other inputs. So how neural network learns? Every neural network, when I say ANN, RNN, CNN, transformer model, generative AI model, what they are trying to do? They are trying to find out the best coefficient values in such a way so that the errors are minimized, and their all role is updating the weights in such a way so that the errors are minimized. And this process we called as a back propagation, right? What is called back propagation? If you are getting errors in your predictions, the errors are back propagated and we update our weights. So this way the neural network learns, right? I'm going to discuss in the deep also, just wait. So what are the types of neural network we have? Like as I am talking about perceptron, multi-layer perceptron, deep neural networks, convolutional neural networks, RNN. Not only these, we also have many other family members of the neural network. Why we use them? To solve different variety of complex problems. So what is called perceptron? Perceptron is the simplest type of artificial neural network and it is mainly used for binary prediction. But we have a limitation with the perceptron. Perceptron can work only if your data is linearly separable, right? When we can create some straight line that any data point which is coming out of it will be classified as Y, any data point which are coming here will be classified X. Perceptron is able to work when the data is linearly separable. When it is non-linear data or other complex problems we cannot work with the perceptron. So to focus on these problems, we have multi-layer perceptron. Multi-layer, it means we will be having more number of hidden layers. The input will pass through the each layer and the outputs of the last layer are the final output of your multi-layer perceptron. And here we can handle more complex problems of non-linear relationship. If your data is non-linear, if your data looks like this, for example, the data points are here, here. Can you create a straight line here to segregate the both classes? No. This is a non-linear relationship. In that case, we cannot use perceptron, we use the multi-layer perceptron. I'm giving you the abstract knowledge right now, not going into very deep. Otherwise, we can show, hence prove it also, how perceptron cannot work with the non-linear data also. So as I was discussing, the deep neural network is a multi-layer computational model that process your data in the layered manner, right? And we refine the information at each layer. As the same, the human brain functions, right? So that we have in the deep learning. Now, one of the very important type of neural network that we have is called convolutional neural network. Convolutional neural network, I discussed about perceptron, multi-layer perceptron. Now, convolutional neural network is something different. Guys, I'm working with images, right? So, do you know the dimension of the images? For example, my dimension of the images is 200 cross 200 cross 3. Suppose I'm working with the color image, right? So total how many inputs will be there? If I'm working with the color image, 200 cross 3, I will multiply it. So there will be so many inputs I will be passing to the ANN, right? So when we work with the images, the ANN cannot handle such a large amount of data, right? ANN are basically designed, simple artificial neural network like these are basically designed when your input data is less. But when I'm working with high dimensional images, where the images may have several height, width, and the color images we have. So we want to, first of all, deduce the size of input data, and that comes under the world of dimensionality reduction. So actually the use of convolutional neural network is to reduce the size of your input data. How? Using convolutional max pooling layers. Convolutional layers are responsible to learn the features from your data like ages, shapes, objects, faces from your data. And the max pooling is going to reduce the size of your input data so that now the 200 cross 3 will be reduced to a size of a smaller size. For example, 14 cross 256 channels will be increases. And then this data I will be passing to my ANN. So use of convolutional neural network is to reduce the size of your input data. Right? So this is one neural network we have. I also discussed recurrent neural network. Now, this is the use of recurrent neural network. As I already told you, RNN is used with the sequence data. What is called sequence data? Where there is a relationship present in the data. Like, I hope everyone, if ever gone to the gym, so gym instructor ask you that which exercise you did yesterday, right? So if you have done exercise number 1 yesterday, he will ask you to do exercise number 2 today. If you have done exercise number 2 today, he will ask you to do exercise number 3 today. Why? Because you are remembering which exercise you did yesterday. And whatever exercise you did yesterday, there is a relation in today's outcome, right? Now we are able to see conventional artificial neural network do not remember what is the output, what was the past output. Are you able to see any feedback coming from output to the input? No. Artificial neural network says you give me the temperature value, humidity value, moisture value. I'll predict what will be the weather today. It will be sunny, rainy, or something like this. But I cannot tell you, I do not remember what was the output I have given for this particular input. So for this purpose, we use the RNN, recurrent neural network. Here you can see, can you see this feedback loop? So this RNN uses a memory to remember what past output given, so that this past output integrated with the current input will give you the new output, right? So it remembers that, for example, the sentence is the clouds are in the sky. So it remembers that till now you are talking about the clouds are in. So that it will give you the next word. Okay, I know for what context you are talking about. So the next word to be the sky, right? So RNN is going to help you out where we use memory that remembers the past interactions, right? Whereas ANN cannot remember. What is the difference between ANN versus RNN? ANN do not have a feedback memory loop where RNN has. RNN gives the feedback past output to the as an input, right? So as I already discussed, how much the data you have in your, in these models. So guys, normally what happens, if you have a very less data, better you use traditional ML algorithms. Guys, there is a saying in the world of AI: simple problem, simple solution. If your problem is only to predict the weather prediction problem, you are working customer identification problem, fraud identification problem, the problem is not complex. Better you define a simple solution using a simple ML algorithms, or using some hypothesis testing, or using some statistical technique. Better find the solution with the easy approach, right? Or if it can be solved through the small neural network, that can be done. It is not like every problem can be solved with the large neural network or deep learning models. No. When some problem can be solved with the simple machine learning logic, small neural network logic, there is no need to go for the large neural network. But if you have a massive data set available, for example, a company says that they want to create their own chatbot. They don't want to use the publicly available ChatGPT kind of model. They have a massive data set available. They have large computation power. In that case, you can create your own LLM. But still, if anything can be solved through the help of the small neural networks or the small models, the problem to be solved accordingly, right? So as I discussed, what is the definition of the artificial neural network? In the artificial neural network, when we talk about ANN, neural network inspired from the biological neuron, artificial neural network where it is not natural, but we want to mimic the way our human brain works, right? So here we have inputs, we assign the weights, and we do the summation here, right? We multiply each input with the weights plus bias, and we predict the output. So this is the definition of simple artificial neuron, where each neuron takes input, add weights separately, sum them up, and passes this sum to the transfer function to produce the nonlinear output, right? So as I'm telling you, we use a transfer function. So what is the transfer function here we use? The function actually called as an activation function, right? What is called activation function? Activation function which convert your output into the nonlinear output. Like we have several type of, so I would like to discuss the components of artificial neural network. What are the different components of artificial neural network we have? Input, weights, which are randomly assigned initially, and that will be learned during the training. Then we use an activation function which convert this processing into the output. So we have variety of activation functions to be used, right? Let me just write the name of those activation functions that we use in artificial neural network. One of the very popular neural activation function that we use is a sigmoid function. Sigmoid function used for output layer. It always predict the probabilities between 0 to 1. You can use a threshold for a binary classification problem. If any output more than 0.5 will be classified as class 1, or otherwise it will be 0. Now, one of the most famous activation function that we use in the deep learning is called your ReLU. ReLU is called rectified linear unit. Guys, ReLU is used not used as a activation function for output layer. ReLU to be used for hidden layers. And what is the use of ReLU? ReLU do not use any exponential anything. ReLU is a very simple type of activation function. It says if your input is positive, if your input is greater than 0, right? If your input is greater than the 0, then the output will be your input. For example, if your input is 24, 24 is greater than 0, then what will be the output? 24. Positive values will be, there will be no change in the positive value. But if you are passing any negative value, if you are passing any negative value, then it will become 0, right? So it do not allow to pass the negative values to the neural network, right? Just a second. Correct. So this is, we use the activation function ReLU. Similarly, we also have one more activation function that we call softmax. Softmax is used for the purpose of when we work with the multi-class classification function. So sigmoid is used with the binary classification, softmax is used for multi-class classification, ReLU is used with the hidden layers, right? Now let me just cover one definition for perceptron. Guys, perceptron, I told you, a very simple type of neural network which is used for the binary classification, and it is work with the linear data. It says when your weight multiplied by the input is greater than 0, output will be 1, otherwise 0, right? So this is the equation for the perceptron we use. It's a very basic equation we have, right? And it is used only data where your data is linearly classified. So what is the working of the perceptron we have? We have input, we give to the neuron, and we give the output. Now, the last thing which I would like to discuss here, after discussing input, weights, we add one bias also. Bias may change the output, may control the shuffling of your data, may control your output. These are the components of perceptron I discussed. Now, just the last thing which I would like to discuss, how neural network learns. So very simple thing we have. We process the input in the feed forward fashion. We passes our input from the input layer to the output layer. For example, I'm working on a regression problem. I want to predict the sale in a particular project. What will be the sale tomorrow, for example? So I am working with the supervised learning data. I know the actual sale is suppose 140. And now my predicted sale is, for example, 100. I have error. So how the neural network will learn? Now we will do the back propagation. Back propagation, it means the error will be back propagated to the all the layers. And what will be the modified? Who will be modified? Guys, the weights and the biases will be modified in such a way so that our basic aim is to minimize the error, right? The sum of squared error to be minimized. And this processing is called back propagation. What is called back propagation? We initialize the weight, we give the current input, we calculate the output. You got error. Who will solve the error? Back propagate the error to the all layers, update the weights and biases. You will calculate the derivative of loss function in such a way so that we will be reducing the errors, right? So this is just the outline I shared, how the neural network works. What are the different components of neural network we have? Input, weights, biases, summation function, and then finally the activation function, which is used to depict the non-linearity in the model, right? So if you are able to understand, can you give the answer for the same? What is the importance of the weight in a perceptron? To receive information from other neurons, to determine the input layer, to determine the activation function, to determine the importance of inputs. What will be the answer? A, B, C, D. I'm repeating. What is the importance of weights in a perceptron? Let me check the answers. Anyone would like to give the answer for this? What is the use of weights in the perceptron? To determine the importance of the input? Will it be the right answer? So guys, here I would like to add the importance of the weights in a perceptron. The information we receive from the other neuron So basically the weights are used to determine the importance of inputs, right? Which input is more important for me? Is actor important or director important or your storyline important to predict the outcome? So weights actually determine the importance of the input, and those are adjusted during the training, right? Okay, what is an activation function in a perceptron? An equation that determines the output of a neural network model, a type of neuron in a neural network, a process of updating the weights in a neural network, or a type of supervised learning algorithm. A, B, C, D. What is the role of activation function? Anyone would like to give the answer? Yes, Shraddha, correct. It is the answer to be A. Ragvindra, I just would like to check. This is the use of the activation function. It's not a type of neuron. The activation function which decide the output of a neural network model, right? Where we use the activation function, guys, output of hidden layer, output of final output layer. Here, finally, we use one function, and that function is called activation function, right? So here, guys, we are ending our discussion. Now, if you want, so let me first of all have a quick recap what we discussed. We discussed here what is deep learning, what is the relationship with the AI, machine learning, and the deep learning. So the basically task of the deep learning is to focus on the complex patterns present in your data, like image, video, text data. We have several applications of deep learning in the field of like computer vision, as we discussed, natural language understanding, speech recognition, right? We also discussed about the types of neural networks. So at least you got to know about who is ANN, who is convolutional neural network, which is used to reduce the dimension. What is the use of RNN? RNN work with the sequence data. Here we give the feedback also. What is GAN? What is transformer models, right? How we train the neural networks, right? So all of this discussion we had just to start the pathway towards deep learning. And I know that, guys, all these applications are working in a real time. If you're interested to work upon, you can choose one of the area and can work on these Python libraries, Keras, TensorFlow, PyTorch. You will find a lot many resources to work any of the exciting project, right? Now, I would like to ask if you have any questions at your side. You all are welcome to ask. Yes.
Thank you so much, ma'am, for this wonderful deliberation. And because we have only 3 minutes left, so we take up two quick questions. Two people have already raised their hand. Ashita, kindly mute two person because we have only 3 minutes left. Ma'am has given a very wonderful and elaborate pathways to deep learning. So we can unmute two participants here
Yes,
who have
ma'am.
raised their hand.
Afzal, you are asking from the field of language, the session has been deep learning for me. Okay, thank you. Right. Yeah, I request everyone, if any one of you have any question, you all are welcome to ask.
Any questions, participants?
So,
Ma'am, Aksal,
I hope to the
one
MCQs,
participant
ma'am, they
is
have
conveying
already.
that from the field of language. Uh, this session has been deep learning for me. Thank you for introducing the newer ideas to us, ma'am. Thanks a lot. Another participant.
Okay. Ashita, can we have a one group photograph? Please, participants.
Yeah, sure, ma'am.
Just we want everyone
Just
to
after this quick question from Dr.
for
Amish
one last.
Srivastav, how to identify weight? How to identify weight for multi-layer perception model?
yes. So, when we have a multi-layer perceptron, first of all, we randomly assign the weight for all the layers. Then we use the algorithm process backpropagation. Using gradient descent, we first of all calculate the cost function. In the backpropagation, actually, we want to find out the derivative of loss function with respect to the weight. And this process happens during the optimization algorithm, like a gradient descent, and we want to find out the local minima. So as we are able to reduce the error, in this way we update the weights during the training. So initially the weights are randomly assigned. If you are using any Python library like Keras, TensorFlow, so there in the convolution layer or in the ANN layer, these weights being taken randomly, and later on these weights updated as we continue with the training, right? I hope I'm able to give you the answer. Thank you.
Thank you, ma'am. Another quick question. What if
Participants are requested to turn on
yes,
their camera.
all are requested to turn on cameras so that we may have a group photograph.
Questions can be mailed to ma'am. Kindly put it in the chat box. You can mail it to ma'am because it's 9:30 and we have to adhere the time.
So let me take one more question. As a person from humanities, how to learn the nuances of deep learning, how and where to start using language dialect research. So Dr. Priyanka, as you have chosen your area, right? As I discussed the life cycle of the deep learning project, to work on any problem statement, first of all, you must need a data set. So if you're working on any problem statement related with the dialect research problem, collect a useful data. So as a beginner, I suggest you can take any publicly available data set. You can find publicly available data set on kaggle.com. I'm sharing the link. You can use a kaggle.com where you will find the relevant data set according to your field. Download the data, understand the data, pre-process the data, and then apply the simple technique first. Try to apply simple ANN first. If you do not get a better accuracy, then you can work with other model. But if you're working with language, I request you can work with RNN model, recurrent neural network model. And in this way, you can proceed for the next word predictions in your language data. There are so many models are available that you can use, right? You can, Dr. Priyanka, you can use easily available an NLP tool. I request you to go for a library, huggingface.com. You will find there is a website. There you will find so many pre-trained available models for sentiment analysis, the linguistic analysis model. Here you will find so many pre-trained models that will help you out, right? I hope it helps. Yeah, thank you. So thank you once again
Thank you so
to all
much,
the
ma'am.
organizing committee.
Thank you, ma'am. Thank you for sparing
Thank
some
you so
time
much,
and
ma'am. And with this,
making the audience learn the pathway towards the deep learning. Yes, Kriti, ma'am.
we come to the end of the first day 2 technical sessions. And we wish the participants to fill the feedback form, and the feedback form will be open till 9 a.m. tomorrow morning, and attendance will be marked accordingly. So tomorrow will be meet at 6 p.m. sharp in the evening. Thanks everyone. Have a nice night ahead.
Thank you once again, Pooja, ma'am. And thank you all the participants.
Thanks everyone.
Thank you, Prati ma'am, and thank you, Ashish sir.
Thank you.